Day 11, Solving Radical Equations. In the Algebra 2 textbook, currently, it associates with section 8.8. Today, our learning target is to be able to solve radical equations. A radical equation contains a variable within or underneath a radical. Example number 1. So, remember, this invisible little number right here is a 2 when we take the square root of something. So, to undo the square root, we can square both sides. So these cancel each other out, so we're left with x on the left, and 4 squared is 16, and we just solved a radical equation. Example number 2, the steps when we solve radical equations is we need to first isolate the radical. That means get everything away from it. So the inverse of a positive 4 is a negative 4, and we now have an isolated radical. Square root of x minus 1 is equal to 1. To undo a square root, we're going to square both sides, so we're left with x minus 1. 1 squared is 1. Move a negative 1 by adding it, and we get x is equal to 2. When we look at example B, we need to undo a division. The inverse of division is multiplication, so if we multiply both sides by 4, we cancel out that denominator, so we have 12 is equal to 1 times anything is itself, so the square root of 3x plus 30. To undo a square root, we're going to square both sides. 12 times 12 is 144, equals 3x plus 30. The inverse of plus 30 is negative 30, which gives us 114 is equal to 3x. The inverse of multiplication is division, and we get x is equal to 38. Our next example, 3, notice our index change. So now we are talking about the cubed root. Well, to undo a cubed root, we can cube both sides. Remember, cubing means multiplying the number by itself 3 times. So 2 times 2 times 2 is 8. The inverse of a negative 4 is plus 4, which gives us 12. Inverse of multiplication is division, so we get x is equal to 4. The last example, number 4, to undo a square root, it's isolated. We square both sides, but be very careful when we have x plus 2, our x plus 3 on the right-hand side of our equation. We want to distribute that out, so it means x plus 3 times x plus 3. 2x plus 14 remains the same for now. Distribute everything in your first parenthesis to your second, so you get x squared plus 3x. Everything in your first parenthesis to your second. When we combined our like terms, we get x squared plus 6x plus 9. I'm going to subtract my 2x. The inverse of a positive 14 is a negative 14. So I'm left with 0 is equal to x squared plus 4x minus 5. I then can use the quadratic formula, or I know this is factorable. X plus 5x minus 1. Set each of those equal to 0. So I get x is equal to negative 5. X minus 1 equals 0, I get x is equal to 1. You want to take or pay close attention. If we plug these answers back in to check, and we take the square root of 2 times negative 5 plus 14, and we set that equal to negative 5 plus 3, you notice you have this radical set equal to a negative. This is a no-no. There, we cannot take the square root of any number and equal a negative, so negative 5 is not a solution. When we plug 1 in, we get a positive number, so 1 is our solution.